Hello everybody, and welcome back to Binary in Minecraft. Today we're going to be talking about the storage system that I tried to make last night and failed, and we're hopefully going to be designing one that works much better for storing binary data so that we can use it in our computer later. So first I should probably explain what I've made here. This was a failed attempt at making a better storage system because at first so you can see my storage system over here. The problem with it is that it's individual levers for each save. You see that, this lever saves this pillar, this lever saves that pillar, and that's important. We don't want to save all of them at the same time. We can't just have one save. That would be ridiculous. But it's really annoying the fact that we have all these different levers. So what I was trying to do over here is have one lever or one button, which would do everything. And well, I made a very silly mistake, which has resulted in the fact that we cannot do that. I don't know if I can get this to work, but if I can, I would like to show you the issue that I ran into. Yeah. So I don't know if you can tell, but this isn't exactly what I was going for. But, yeah, and actually I don't even remember how to shut that off. Oh. What the? Okay, what is redstone then? I realized afterwards that my explanation of what the actual goal of this contraption is was very bad. The idea is just that we can have one lever which saves each individual save. Instead of having individual levers for each save, we just have one lever which can save each of them, or a button in this case. I hope that's slightly better, but it's just for saving binary data, and it's easier to work with. But yeah, the way that we're going to accomplish that is we're going to use lots of AND gates and lots of wires, and this right here is my attempt at a system which we're going to have to do it differently, and it's going to be a lot more expensive, but I want to show you the general concept super fast before we start doing a bunch of this. So I want to super quickly explain a circuit that we're going to get a lot in this, which is this little circuit right here, sometimes called a T flip-flop. That's probably what I'm going to call it. And I'll explain what it does in a second, but first I just want to talk about why we need it through examples. So you can see here we have a piston with a button by it. And if we click this button, it'll push out the block, and then it'll pull back, because it's a sticky piston. And so it just pushes it out and pulls it back. Then with a lever, what happens is we flick it down, it stays out, flick it again, it's pulled back in. So we could just flick it like that and it would stay out. Now, let's say instead of having a block here, we had our cauldron with water, like this. Like we have over there. You can see that we can push this out, and if we want to take a reading, if we want to read the charge, if we want to see whether or not this thing is full, we need to have it extended. This is kind of like the off state, and this is the on state, or unsaved and saved, which you can almost see what's going on right there. So the idea is that when we press the button once, then it will push it out, and then it'll leave it there. Now you can see that almost actually worked there. The problem is that because it's an observer, it reads, or I guess it notices, that the torch turns on, then notices the torch turns off, and so it just pulls it right back and everything breaks. Now that's not what we want, but there's a different system, which is where our T flip-flop comes in. I'm going to replace this with a cauldron really quickly, so you can kind of see the point and how we're really going to use this. But yeah, you can see this is the T flip-flop design. We have our cauldron, which pushes out, and what we would do is when we hit this button, it shoots it out, and when we hit this button again, pulls it in. Now the idea is that what we would have is we would have this button, okay? Which would be this button right here. There would obviously be more wire in between, but this is the idea, is that it would shoot out, And it would check right here with an AND gate to see whether or not essentially it would check if the cauldron is already here. Check if this is saved or not, right? Now, given the fact that it is not saved, we would want it to save it when we click the button. But if it is saved, then we don't want it to save it, because that wouldn't be saving it. We don't want to update it if it's already saved. Let's say that. So we hit this button, we would put it through an AND gate, where we would check the output right here. So let's leave ourselves some room. Let's put this here. Grab one of these. This. Bam, bam, bam. So then we would take, this wouldn't be the only thing, but we would have one of the outputs be, actually we're going to need a repeater. We would have one of the outputs just loop back around. To, oops, right here. However, one thing that we have to do, because of the way that AND gates work, is that we actually need to NOT this, because otherwise it would never let anything through. So the default, when our cauldron is not moved, when our number is unsaved, then we let the charge through and we let our number get saved. But if the number is saved, then we don't let the charge through, like that. Then we don't let it through, and so it'll stay there. So I forgot to put in our T flip-flop, but I just installed that. And now our system should work and we can test it out. So we currently have not saved this imaginary number, okay? But when we press this button, now it's saved, okay? And now you can see that because it's on, now the AND gate is locked because this wire's off. So if we press the button again, it doesn't do anything to this because we want it to remain saved. So we could have multiple of these next to each other where, let's say, we're going to have to get rid of this. No, we're going to leave this here. We're going to do it the other way. We could have one button right here, you see, and we run this like this over here, and it goes like that. And then we can run this into another one, right? That way, if we already have a number saved here, it doesn't matter. It doesn't change it. It only changes it if the number is unsaved. So hopefully you're starting to kind of see what the plan is here for storage. We have this one button down here, which when we press it, it will save the first one. And then if we press it again, it'll save the next one. And then it would save the next one. And that's just the order. So that way we can have one button which can save multiple files. Or not multiple files. Multiple bits. Much smaller. But, yeah. So, you think, maybe we're good now, right? We have these two things connected. Everything's wired up. Here's the problem, though. We hit the button. Both of them get used, which is not what we want, right? We only want this one to fire. Now it's good, we have the part where it doesn't fire again, but we only want this one to fire when we press it the first time. We want it to save the first unsaved one, I'm not done with the next clip, but there's a spider near me and I'm really scared. Oh my god. Hold on. Okay, he's gone away. I think we're safe. Jesus. I hate spiders so much. So, I have gotten us into our new system where now it should work. And I'm going to explain this only thing that I actually changed here. So you might see that I broke it and moved it over a decent amount. And that is just because I had to add one small piece, which is an AND gate, which basically just says, if this is saved, and the button is pressed, then, you know, continue on and trigger this one. But if it's not saved, if this isn't saved, then the redstone line, the redstone button press, will never make it over here, and therefore, nothing will happen over here. So, let's test it out. We want to save, we just click the first button, and it should save that one. Correct. And it didn't work. What happened? Hold on. So I think I figured out the issue, and yeah, that was my first live test. I think that this one, this charge, makes it all the way over here. It doesn't make it here fast enough. Like, it's not... We need to slow this down, I think. Maybe not a lot. Damn it, okay. We need to slow this one down a little bit. That way it doesn't make it... Yeah. So maybe it should work now. First of all, let's see if it resets. See if this part still works. Good, alright. Okay, so I think I've gotten it back to working. Oh, I'll show it on one part. We gotta do something over here. We gotta add right here. Okay, so now that should all work. Let's see. Bam. Fuck. Okay. Nope, nope. Okay, I think I see it now. Okay, I think that we actually needed to slow down this one. Yeah. Yeah, no, I'm pretty sure. I'm pretty sure that's what we needed. So if we just flick this, live test number 3. Boom. I even think that it almost worked. I think we just need to delay it more. Hold on, how long does this last? Hold on. I think that I figured out. I think we just need to delay it even more. You know, I'm not even gonna cut this one. I'm just gonna let you guys see this and everything that's gonna happen with it. So we're gonna try to delay this a little bit more. Now, obviously, we don't really want delay, but actually, saving delay isn't really that bad. Delay in other systems is kind of bad, but saving delay isn't the worst. So perfect. And then if we hit it again. Woohoo! That is perfect. So there we go. We have this little system, and as you can see, we just got to keep going. We got to put the AND gate at the end, and it will just keep going, and we can do as many saves as we want. Now, are there definitely ways to make this smaller? Yes, especially using, you know, multiple levels, using vertical stuff. But I think this is a pretty good representation and a pretty good plan of how we're going to do this. I want to add something at the end because I feel like it might be confusing what exactly this is. So these lamps right here will then run right here, run into here, and then it'll do, this is where we put these pillars. If you remember these things, where it runs up like this. That's where this is. So this is going to be a lot longer and honestly much less efficient, but it's necessary in order to allow us to do one button saving. But this is everything we need. This is how to make one button saving in this game. And so this is step 1. I mean, we've done it. We've tackled step 1 of the process. And we can actually hook this up to this system now. Now we're going to get rid of this, and then I'm going to hook it up, and you can see it. But yeah, so I've attached what we had over there to right here. So now, if I just super quickly, I'm going to reset our little system here to the point where now we're back to the unsaved state. And let's say I want 10. Okay, I can click the save button, and obviously this would be much closer to the panel, but now we have the save button, and now you can see that this one is saved. And we click both of them because we want 1, click save, and now that one is also saved, and our data storage system is done. I mean, that's most of what we wanted, right? The only thing that we're really missing is, well, first of all, we want to connect this up a little bit more, but we don't have a way of resetting our storage. And while that may sound like a very scary problem that you may not know how to fix, it's actually really, really easy, using some of the stuff that we've already made. So we're just going to hook this up here. Obviously there's ways to make this much prettier, but we have our little system here. Everything hooked up there. Oops. And so we got that, but now we need some way to reset our storage. How do we do that? Well, it's actually amazing because this little pocket here is all the space that we're going to need to do this. So now we can get started here. As I was saying, we can get started here. And actually, I changed my mind. I don't know if I said this out loud, but I'm going to have this be a button because it's actually going to make this even easier than it was before. So let's just quickly wire this up. And where we're going to wire it is we're just going to power these pistons and force them to reset. So we're going to ignore all of the AND gates, all of the logic, and we're just going to run this straight into here. Now we don't want to interfere with any of the redstone that already exists. That should be good. And we just want to run this over here. And so right here, we would run this down to there. Little repeater. And so the red will just force it to fire. Oh, I've not heard the song before. It's a little loud. Where's the audio settings? Turn this down a tiny bit. Not bad though. And then we'll just do the same thing over here, where we force this one to fire. Oops, can't have it there. Oh, I've heard this before. Never mind. Yeah. Yeah. And that should really be all that we need. So it'll just force the pistons to fire, and so that'll retract them. Now, one thing is that this can also force the entire thing to save, which, I choose to think of that as a feature, not a bug. And so let's test it out. Let's hit the kill switch, that's what I'm going to call it. Let's hit the kill switch. And yeah, that forced everything to fire, reset everything. And now we can save new stuff. Save that first one. Save that. That's saved down there. And then just hit the kill switch and reset everything. Awesome. And, that's pretty much it. Obviously we need to do the test to make sure that we can actually remove the data. which if we just check that super quickly right here, we definitely should be able to. Because, you know, these don't need to be redstone lamps, it's just for convenience. Okay, this song's really loud. Hold on. I'm sorry. Okay. Yeah, and I mean, as you can see, we can absolutely run the data out of here, despite the fact that it is successfully saved. And so there you go. We have successfully made a much better storage system for data in Minecraft. Yeah, so thank you for watching. I'm gonna really start on the computer soon. Just want to get these components laid out so that you can really see what's going on, because when we put this in the computer, it's gonna be much more compact and much less easy to understand. But yeah, I hope this helped, and have a good day. Bye.